Hello, this is Spy, and this will be the 7th video of Unit 1, Section 7, on what is an inverse function. I'm not going to go over how to find the inverse, really, more what is the inverse. So let's begin. Okay, so intro to function inverses. This is really an introduction to what a function inverse is, not to work with linear inverses and other function inverses. That will be much later on. Okay, so characteristics of inverse. It's a reflection over y equals x. Some students like to think of it as a rotation 90 degrees. It's really not. It's a reflection over the line y equals x. What you do is you switch the operations usually. Notation is f to the -1 of x. Domain and range switch an inverse. Sample, the function inverse of 0.5 -3 is -3.5. The x becomes the y becomes x. Not all functions have an inverse that is a function. Some function inverses are not functions at all. A good example is the absolute value of x. Its inverse is not a function. Verification. If you compose with its inverse and it equals x, or if you compose the inverse with the function, it is for sure a function. Okay, so find the inverse of the graph. The way you do this is you look at the y value. So the input to the inverse is the y value. So here the y value is 3. So the x value is 5. So at this point. Let's look at the next one. If my y value was 1, my inverse would be 3. Okay, so now we plot those 2 points. Okay, so we have one point at 3. We have one point at 3 at 1, 3. And another point at 3, 5. So that's up here. And its inverse would look like that. It'll sort of look like it's going the opposite way of the function. Looks something like that. Okay, so we'll go at one point's 1, 3, and other points at 3, 5. I can't really plot 3, 5, and I'll sort of make this shape. Okay. Now this one goes this way. Its inverse will make the other type. We call that concavity, but that's not important for now. Okay, let's look at another example. Okay, find the inverse of a table. Well, when you have a table, it's really simple. You just switch the x and y. The x becomes -1, 3, 6, 9, 12. I just read order of numbers from least to largest in ascending order. And then we have the inverse f -1. So at -1, it's 2. At 3, it's 0. At 6, it's 19. At 9, it's 7. At 12, it's 4. And you notice it's an inverse because none of the numbers repeat over here. So you just flip domain with the range. And that's it. Another example. Basic inverse functions. Now, anytime you want to find the inverse, you just do the opposite operation. So instead of f of x plus 3 becomes f at -x. -1 of x equals x minus 3 instead of plus 3. For minus, you do the same thing. Instead of minus, it becomes plus. So f, the inverse of x minus 9 is x plus 9. Okay, keep on going. Inverse of multiplication, division. So if it's 6x, our inverse will be x over 6. The inverse of division is multiplication. So the inverse of x over 5 would be 5x. Last example, one with a fraction. The inverse of a fraction is the reciprocal. So the inverse of 8, 5 to the t. So in this case, we're using r, not f. So r to the -1 of x. So if not of x, of the t would be 5 over 8, because the reciprocal of 8/5 is 5 over 8. So anytime you look for the inverse, in basic cases, you're looking for the opposite operation. So it's addition, subtraction, F subtraction, addition, multiplication, division, division, multiplication, exponent, logarithm, etc., etc. Remember, also, fractions use the reciprocal. Let's continue. Okay, some a bit more challenging. The way to find the inverse is you solve the equation for x. So you first do, you first do 2/3 x equals y minus 11 instead of plus 11. Then to get rid of the fraction, you multiply by the inverse of the fraction, is 3/2. These cancel, left with x equals 3/2 y minus 33 over 2. And you get f inverse would be 3/2 y minus 33 over 2. And very often we like to write it as 1 fraction over 2. We call this inverse notation. Okay. Okay, some people like to switch x and y and solve. I'm not a big fan of that method. Yeah. Let's continue. Let's clear up. And let's do the next problem. Okay, same thing. This time, let's do it the other way. Y equals 2 over x plus 3. You want to solve for x. So y times x plus 3 equals 2. And we're trying to get x by itself. So distribute, so it's xy plus 3y equals 2 minus 3y on both sides. X times y is negative 3y plus 2. Divide by y. Divide by y. Divide by y. X equals negative 3 plus 2 over y. Okay, this is a little bit of a different one. And has a domain change where y cannot equal 0. So the inverse would be f of negative 1 of x equals negative 3 plus 2 over x, where you may want to restrict your answer where x cannot equal 0 when the original function x cannot equal to negative 3. And we're not using f this time. Got to be careful about that. Using h. Okay. Copy down what you need to. I'm going to clear it up and do the next one. Very similar. Okay. So let's try last one, m. So in this case, we'll do it again. Let it equal y. Solve for x. So it becomes y times 2x minus 7 equals x. We have 2xy minus 7y equals x. Switch the x and y. So we'll minus x on both sides and add 7y on both sides. So we get 2xy minus x equals 7y. Factor out an x. So it's x times 2y minus 1. Take out what's in common. There's a 2 and a y here. So I take out the x. Here I just have an x. So I leave it with 1. Equals 7y. Divide by 2y minus 1. 2y minus 1. So x would be 7y over 2y minus 1. Write it as an inverse. So m negative 1 of x equals 7x over 2x minus 1. And remember, anytime you have a denominator, you got to restrict the domain. So in this case, x cannot equal to half, and the original function x cannot equal to 7 halves. I'm not going over how to find that, but if you want to remember, you set the denominator equals 0, so 2x minus 1 equals 0, and solve for x. So you'll be 2x minus 1 equals 0, add 1, 2x equals 1, divide by 2, x would be 1/2. Okay? So those are some simple inverses. There are much more complicated ones, and we'll see those as we go throughout the year. The inverses of exponents, inverses of rational functions, polynomial functions, all functions that have inverses that are functions, and how to find them. Let's continue. Okay, show that these functions are inverses. Now this is something where you want to find the inverse. So to find the inverse, remember the definition is f of its inverse has to equal to x. So I got to plug first one function for x and see if I get the inverse or not. So let's first plug g into f for x and see if we get x. So we're doing here first f of g of x. So the 4's cancel, left with x minus 10 plus 10 minus 10 plus 10 equals x. So far, it works when I do f of g. To fully verify, we got to do it in both directions. G of f also. So 4x plus 10 minus 10 over 4. So you put the function in. 10 minus 10 is 0, so it's 4x plus 0 over 4. 4 is answer, plus 0 is just x. So it works in both directions, gives you the same x. So in order for a function it has to work when you put the original one function. So you put g into f, and f into g. So g of x is equal to the inverse of f of x, and f of x is equal to the inverse of g of x. We verified that these two functions are inverses of each other. You have to do it in both directions and try to get x both times. Another way of doing it is plugging in the same number into both and getting the exact same results. Like if I would plug 3 in for x, 4 times 3 is 7, 4 times 3 is 12, 12 plus 10 is 22. Now, if I plug 22 into the other function, 22 minus 10 is 12, 12 minus divided by 4 is 3. So if you plug in the point, they'll give the domain will become the range, the range will become the domain. That does not work because this is the only way to check for general case to see if you get the same exact x value. Let's continue. Okay, so the next video is the final video of this unit. It's the overview of some key features of a function. This is based on videos of today's lesson in 12 of the fall 2020 school year. Okay, hope that was helpful. A quick overview of inverses. Watch out when we get to unit 2 when we cover inverses of linear functions in the upcoming weeks. This is Mr. Spy getting ready to prepare for the last video of this unit. Hope this was helpful. Subscribe to my channel. And if you have suggestions of other videos, please place them in the comments below. This is Mr. Spy signing off.